Okay, welcome to today's class. For today, I'll help you solve question 8 of your tutorial sheet for chemical kinetics. So before I start, just ensure that you subscribe to this channel so that whenever I post something, you'll be notified or updated. So let's start. So what's the question saying? So the question is saying, consider the reaction. So the reaction has been given here where you can see nitrogen dioxide decreasing with time in order to form nitrogen monoxide plus oxygen gas. And then the question continues by saying the lead constant at 650 Kelvin is 1.66 per second. And then the other lead constant at 7000 Kelvin is 7.39 per second. Calculate the activation energy. So how can we calculate for the activation energy? So the first thing, we need to come up with our data. So the question is asking us to find the activation energy. And then we need to know that activation energy is given by in ln of the final lead constant over initial lead constant is equal to the activation energy, the one we want, over the gas constant R, open bracket, 1 over the initial temperature minus 1 over the final temperature, like that. And then here, from the data given, we can come up with our data. So our initial temperature, T1, according to the information given there, it's 650 Kelvin. And then the final temperature, according to the data given there, the information is 7000 Kelvin. And then the lead constant at initial temperature, which is K1, the lead constant at initial temperature, is 1.66 per second, like that. And then the lead constant at final temperature, which is K2, is 7.39 per second, like that. And then there we need to know the gas constant R, which is 8.314 joule per mole per Kelvin, like that. And then we can substitute in this equation. So we're having in of what's our lead constant, K2, which is 7.39 over the initial lead constant, which is 1.66, like that, is equal to the activation energy, the one we want, over the lead constant, the gas constant, which is 8.314 joule per mole per Kelvin, like that. Then 1 over what's our the initial temperature, which is 650, minus 1 over what's our final temperature, which is 7000 Kelvins, like that. And then here on your calculator, if you punch ln of 7.39 over 1.66 on your calculator, you're going to get something like 1.493310132592, like that, is equal to the activation energy over the gas constant, which is 8.314. And then on your calculator, if you punch 1 over or divided by 650 minus 1 divided by 7000, you will get something like 1.3956 times 10 to the power negative 3, like that. And then our aim is to solve for the activation energy. So what can we do? We'll divide both sides by this same 1.3956 times 10 to the power negative 3. Even this side, 1.3956 times 10 to the power negative 3. So once we cancel this side, then we divide this side. So when you divide 1.4933 1013252 divided by 1.3956 times 10 to the power negative 3, we'll get something like 0.00107, like that, 7,962. So this is supposed to be 2, like that, and then is equal to activation energy over 8.314. And then here our aim is to remain with the activation energy, so we can multiply both sides by 8.314, even this side by 8.314, so that we can get rid of this 8.314 down here. So this one goes. So our activation energy is equal to, so we need to multiply 8.314 times 0.00107009622. So after multiplying on your calculator, you get something like 8.896 times 10 to the power negative 3 joule per mole. Once you are having this, your activation energy should be in kilojoule per mole. So your activation energy, the final one, you need to multiply this one you have found by 1000. So we need to ensure that it's in kilojoule per mole, not in joule per mole. So we need to know the conversion that 1 kilojoule is equal to 1000 what joules. So divide that by 1000, you get something like 8.896 times 10 to the power negative 6 kilojoule per mole. So that's our final answer. So unless there are questions, if there are questions, you can contact me so that I can help you out. Lastly, don't forget to subscribe, like and share, and thank you for watching.